So welcome everybody to our webinar today, Data Science for Engineering. Just a bit of housekeeping to start with. You can ask questions at any time. Please do so in the chat window. And at the end of this webinar, we will have a few minutes to answer those questions. Thank you. So a little bit about myself. My name is Anthony McLaughlin, and I lead Altair's data and AI business in EMEA. My background is quite unique. I'm an engineer and a data guy. My engineering background, I'm a mechanical engineer. I specialized in aerospace. I worked for Airbus back along. And I spent, after that, about over 10 years helping companies, enterprises, particularly in Central Europe, to revolutionize their product development cycles with advanced computational aided engineering. In recent years, I became a data guy. I worked for a leader in the big data space out of Silicon Valley, and just recently, then, end of last year, rejoined Altair. Probably why I rejoined, one of the big reasons, what I firmly believe in is that engineers like ourselves on the call today, we're going to be the key to unlocking AI at manufacturers. So that being companies that make stuff, planes, cars, Hoovers, etc. Today is about the big picture, so we're going to keep it a little bit shorter today. It's about, first of all, some people on the call may have been hearing all these buzzwords about AI, so we just want to level set what is AI and why is it so game-changing? Why engineers are key to unlocking its potential? Where is the adoption today in the industry? And why practical AI is needed to empower engineers. And finally, we'll talk about how engineers will help do it better. There will be a follow-on webinar where we go in more depth, and it'll be a technical session to show you how to get there, how to become a data scientist, the path to data science for engineers. But today, big picture. Okay. So let's just start off with what is AI. So before I went to the data world, I would hear all these buzzwords and it sounded super complex and very like science fiction, what's deep learning, etc. I can tell you from experience that for me, AI in a nutshell, we leave general AI to the side, but in industry, what AI is, it's actually just simply data-driven decision-making. And in most cases, from what I've seen from use cases and helping customers, is that quite often it's not as advanced as you may think. In 80% of the time, it's usually just about getting the data together and getting it to the right person to visualize it, to take a better decision, in-time decision to improve their business. For example, I measure that a robot in a manufacturing plant has a certain vibration. I get that to the expert in time on the shop floor, and they can schedule some maintenance for that instead of that unscheduled maintenance. And that's really all about automation. Automating, gathering of this, ingesting of this data, cleansing the data, combining the data, making it ready to visualize, consume, and then also for advanced analytics. The other 20%, of course, there is advanced analytics ongoing. The data science, the machine learning, there are use cases, of course, where this is being used. And really for me, that's like, what is data science, machine learning? For me, it's like the next level of software. So software today, if vibration, something happens, do this, if else. You have to code it, write it, and inform the software what to do. If there's a vibration, a certain vibration on the robot, please tell the operator to take care and possibly schedule some maintenance. Now, as the world becomes more complex, there's much more data being generated every day, and there's much more connected data. These use cases and these really impacting business, the problems become more complex to solve. And this is where data science and machine learning comes in. That helps find patterns and help answer to find automatically if this happens, then do that. And that's what I mean with the next level of software. Okay, so why is data and AI so game-changing? I'm going to speak to some examples here because I know them firsthand. I worked a lot with the automotive industry in previous years, in Germany in particular, and also with leaders like Capgemini. And before I did that, I heard a big, again, for people on the call, you may hear this stuff and you're not involved in it. You hear a big headline: automotive OEMs can boost their profits by 5 to 16% by doing AI at scale. And before I went to the data world, this is like, I don't understand, what does that mean? Is that just hot air, marketing, blah, blah, or what's behind that? What does that actually mean? And it's a great study here. I've sourced it at the bottom. You can read it afterwards, I would recommend. And what Capgemini did was they looked at use cases across the various divisions for a automotive company, OEM. They looked at use cases in manufacturing and engineering and supply chain, etc. And they mapped out the high benefits, so high value use cases that bring a 20, 30, 50x business value, return on investment. And they mapped that against the y-axis, which is the complexity of the use case. How difficult is that to actually implement? And let me just give you one of those little dots, an example, because I can speak to this. I helped and worked with German OEMs and teams to actually implement one of these use cases. And you hear the smart factory. What does that mean? Let's take one of these use cases in really, really simple terms. Let's take a robot arm machine, a welding machine, let's say, and really what you do is, if you can gather the data, for example, the log files or some sensor information, and you understand how the robot typically breaks, and you can then get that data and information in real time to the people who know, the industrial engineers, the operators in the factory floor, they can take decisions. They see an abnormal vibration, they'll know what that means, and then they can schedule some maintenance in the next shift instead of letting it go out of a break and then there's unscheduled maintenance. And first of all, that's just data, right? Not even the machine learning. You can go further and use machine learning to predict more in advance. Next week, this robot possibly could break. But even just getting that data together, what does that mean from a business perspective? Typically, you can get a double-digit uptime increase for that machine. And then if you do it for more machines, all the welding machines, and then you do it for the welding, and then you do it for the painting robots and the gluing robots, and etc., you can get a factory efficiency increase 1%, 2%. Doesn't sound like much, but that's massive, particularly in Europe where we have high efficiency in our factories and in automotive. A 1% increase in a factory, an automotive factory, a large manufacturing plant is millions of dollars or euros of savings per year. And then if you scale that across more factories, all the factories, you can get tens of millions of euros in savings. And the reason I tell you this is because the scale aspect of AI, teams who have implemented this have been maybe 5 people, data scientists, data engineers, etc. And you can then save tens of millions. You can make a massive impact to your company and to your industry with very few people. And that's why AI is so game-changing. If you take that use case plus the other use cases and you combine them all together, you can see why what Capgemini's study is saying here is actually quite true and it's happening. Okay, so where are companies on what's a typical journey companies and enterprises go on? So first of all, a company wants to start out, they have no data or they don't have their use cases yet and they're trying to get themselves organized. Next, they'll start piloting, they'll identify some use cases to start with, ideally those high value, low complexity use cases where data is available. And it's all about proving the value to get investment, to convince management and convince end users how great this stuff is and to invest in it. Then further, the next step is typically an enterprise to consolidate and incubate the technology in what we call a center of excellence. And that's really about productionizing those first use cases, making them successful in all those factories, and then incubating and driving further use cases. The last step in their journey is AI at scale. That's really about being a data-driven company, something like your Netflix, etc. So looking at the automotive industry, in Germany in particular, the top 3 OEMs, they're somewhere in the COE here. Some are more ahead of others. I'm not going to put the names in here for obvious reasons. And you've also got some tier 1s who are very innovative and investing heavily in data and AI. But actually most of us, most companies are at the starting phase in automotive and for other industries. Automotive is a bit further ahead, in my view, compared to other manufacturers. So most of them are just starting out, to be honest, and I think a lot of you on the call probably as well. And some are here and nobody's over here. And everybody has the same pain. There's not enough data scientists. So we'll speak about that in the next, in a minute. But first of all, we'd like to take a quick poll. We'd be very interested to see where you are on your journey. So a poll should come up any second. Poll open. Okay. So where are you on your journey? Getting started, piloting your first use cases, addressing internal capabilities gap, building a center of excellence, or implementing AI at scale? Okay, very interesting. So most of you, 71%, are getting familiar with AI and 21% piloting the first use case. So far, I'm not far off the truth, right? Most of you all are clearly here. 93% are over here in starting out in piloting. Quite normal. Okay, so let's move on. Okay, so if we agree, AI works, but it's not scalable. Okay, so to make AI work right now, you need a lot of IT computer science experts. You need data architects, data engineers, and data scientists. Most of you would have heard of the term data scientist. And what does a data scientist need to implement a successful use case? A data scientist will need 3 things mainly. 1, be able to code and understand what Spark is, code in or Python. Then we'll understand architectural aspects, etc. Number 2, we'll need to understand math and statistics. What is gradient-based optimization, etc., to do data science and understand what comes out of, for example, machine learning. Then the third thing is you have to understand the data and the use case at hand. How does that plane have a fatigue problem, why it has a fatigue problem, etc. And that's really like difficult, okay? These are unicorns. And there's tons of studies out there, but there's simply not enough data scientists. The recent one by Forbes, 250,000 data scientists estimated deficit in the next 3 years in the US alone. And even if you do get these unicorns, they're really tough, they're very expensive to get. And even if you do get them, their productivity is only about 20% of the time. Various studies have confirmed that. That's due to many things, data challenges, etc. But this is not scalable. And today, the whole AI and data, from what I've seen, is, and we've seen, is dominated by computer scientists and IT. This is good. You need computer science and IT to make this stuff work, but it's not enough. And the real big question is not actually how to scale. This is the wrong question. We believe that the right question to ask is who to scale. Who is going to do all this data science? So what about the millions of engineers? What about all of us here in call? Most of us are engineers. I'm a mechanical engineer. There's 3 million of us in the EU alone. What about the industrial engineers, the quality engineers, et cetera, et cetera? Okay, so think of those three bubbles again. We as engineers, yeah, we know math and statistics, of course we do. And we know enough of it to make the jump to data science. That's not the tough part. We know, who knows better than us how the plane brakes, the car brakes, the robot brakes. Who knows that better than the people who developed it over the years, the experts and the people who maintain these machines. The issue is computer science part. Computers or engineers, most of them don't have that experience and they don't want to have it. We want to drive use cases and implement them and not want to learn how to use Spark and S3 bucket and all these sorts of stuff. And that's really the key challenge. So our vision in Altair is that tens and even hundreds of thousands of engineers will be doing data science, taking data-driven data decisions, and they will not need to know computer science or code. Let me sit that's it for a second. So how we help in Altair is we empower engineers and computer scientists, what we call practical AI. What is practical AI? So this is a typical setup, what you need to do data and data science and AI and that stuff. Altair acquired a company for 2 years ago. We were previously an engineering company, and now we're an engineering and data company. We bought and pretty much merged together with a data company that's very successful in the banking and finance industry. And they have generic tools for doing data preparation, getting all the data together from all the different sources in time, in quality, and in security, and making that ready for data science, and then do data science tools, and then to visualize that data in the end. And Altair's become now an engineering and data company. And the big thing about these tools is they need to be more practical, okay? The blue box you see here, all this stuff is very important from a computer science and IT aspect, security, data lineage, data quality. The interfaces is a massive topic. How to get all that data together from your SAP, from your ERP, from PLM, from cloud, on-premise, data streaming, real time, all that stuff. That's all the IT part, and it's super important. And that's the part we want to automate, look after, so that people above can work and drive use cases and don't need to worry about it. And that's what we mean with practical AI. Number one, it's easy to use. So it's a self-service, low no-code solution. That means you can click and drag and drop to build a data pipeline, train your machine learning models and deploy them without needing to code. So citizen data scientists, engineers, and it has to be affordable. Number two, it's very expensive today to make this stuff work. It costs too much to the software and also the implementation costs. Super expensive to do a pilot. And this has to come down. It has to become affordable if we're really going to democratize this technology and get the whole value out of it. Number three is it has to be open and extensible. It cannot be a black box, closed black box. This is important because the citizen data scientists, the engineers, we believe, the 80% of the users, will rapidly develop and deploy use cases in the first factory. But then later, you need the expert data scientists and IT to scale it across the world for the 100 factories. So you have to be able to export that code and put it into Azure, Data Lake, etc., and Data Factory, whatever, to make that work and scale it across the world. Okay, so we're pretty excited. This trend is happening, and we've got many proof points. One of the biggest ones recently we're super excited about is we joined forces with Rolls-Royce, so the aero engine manufacturers, and they are anyway just a fantastic brand, very innovative company, and they see the future as well. The future is this convergence of engineering, data, and AI, and they have the same vision. Our engineers take data-driven decisions because they know how transformational it will be for their business and their products. And for them, they want to do this, but they don't want to become computer scientists and programmers. They don't want to program. So low code is definitely the future, and we believe even further, and Rolls-Royce also, that engineering know-how and data will actually help do it better. So I'll speak about that in a minute. Here's just one example I would recommend to read if you want to know more about that. Karsten is an example. He from Rolls-Royce. He is a CAE background systems engineer, and he made the jump to data science and runs and helps others at Rolls-Royce to make that jump also. He did a recent presentation at our conference end of last year. The link is here in the slides. We'll send it around afterwards. And he talks about how that convergence and how combining data and AI, or engineering and AI, will be able to speed up game-changing impact for the development of new engines, faster and more cost-effective. Okay, so some sample engineering-driven data use cases. So why we show this now is because at the end of the day, everything is about the use case in data. So it's all about start always with the use case. You look what data is available, and then you try to identify use cases, high value, low complexity use cases, and that's where you start. It's always about use cases. The value is in the use case and in nothing else. Okay. So what are those sample engineering data-driven use cases we're seeing at Altair? We're seeing mainly three buckets where we feel engineering is predestined to drive. Number one is the CAE space. So data use cases in the CAE departments. Number one, of course, in our Altair products, we are implementing machine learning and leveraging the technology to improve our core products. So, for example, in HyperMesh, automatically identifying similar parts, machine learning is great at that. That is a feature to help speed up the pre-processing tasks. Number two, of course, in product design, where we've been leading for many years with OptiStruct and etc. I would argue that OptiStruct is AI, but really reducing development time by leveraging machine learning, AI, and complementing HyperStudy, OptiStruct, and the stuff that's already there in CAE. On the other side are really massive use cases. Okay, I just want to call out a couple of them. Warranty analytics, I can talk well to because I worked with teams various teams in various companies doing warranty analytics. I love this use case because it's a perfect example of high value, low complexity. So you can take the data, let's take cars. There is a warranty issue on a car, a battery problem, and the question comes back to engineering. Do we have to recall 40,000 cars? Yes or no? And we need an answer in 2 weeks. Otherwise, we're going to get fined a couple of $1 million. So what happens there? You can imagine. So, but now many automotive companies have successfully implemented warranty analytics use cases where their engineers are using decision trees, so they're getting the data together, how the car is being driven, where it's being driven, what temperature and humidity and climate has it been used in, what suppliers were used to build up that battery, how the car, how long has it been in service, etc. So you take all that data together, and very rapidly with decision trees, you can do root cause analysis to figure out what's really driving that quality issue. It's a supplier with a high, a certain loading profile of the car. That's what's driving that quality issue. Therefore, we can take very quickly, in a couple of days, a decision to recall 20,000 cars instead of 40,000 cars. That's massive, and really those types of recall rate reductions have been achieved. That is multi-million euro savings on that one question example I mentioned alone. So these are really big use cases, and there's not even machine learning or really advanced analytics used in such a case. Other ones are kind of, we see new use cases popping up through this combination of engineering and data. Testing analytics is a great one for engineering. All that testing data that's sitting around being generated every day. Using machine learning to avoid tests, you mine the historical tests, and you can actually, we're helping clients in plastic manufacturers, steel manufacturers, also product manufacturers, mine that data and then be able to actually avoid tests. From the past, we know this should be the answer. In a way, it's a virtual test. When you have to do a test, you can use machine learning to reduce the amount of sensors needed for a given test and where you should install those sensors. That's massive for certain companies, especially complex engineering products, where testing costs are very high, and this sensor can be linked directly to recurring revenue and lead time for that development program. Lastly, of course, you can use machine learning to predict anomalies in a given test. So the aero engine, for example, does not part to break, and you have to rebuild the whole aero engine, restart all the testing, that sort of stuff. Lastly, one I'd like to talk about, and I have a slide on this next, is quality analytics. So in the on the manufacturing floor, again, think of those robot arms or those machines and those presses and so on. Real-time monitoring quality issues in the production on the plant floor, and using machine learning to predict and avoid those issues. Again, using decision trees to do root cause analysis to understand those problems, and then machine learning to predict going forward. And of course, machine learning being used to optimize the machine setup for a given manufacturing process. That is a huge impact on part quality and plant efficiency, getting it first time right, avoiding rework and scrap, and this sorts of stuff. Okay, so let me give you one example. Ford, a customer of ours, was very kind to let us speak about this. So a stamping process in Ford, in their engineering and in their manufacturing plant, and they use data and machine learning to improve this part stamping process. So they mined all the historical data from engineering and from manufacturing, and they were able to train a machine learning model to automatically predict the optimal stamping process. How do you set up your machine for a new type of stamping? And they were able to get a near 100% accuracy in that process setup. And through that, again, they save a lot of waste and they get a first time right, etc. There's a huge business impact for them and improvement through the single use case. So you see, what does that actually look like? On the right-hand side, you see this was modeled in one of our tools in Altair called Knowledge Studio, where you build that data flow and then you train your models, you pick your algorithm, and then you visualize the results and you deploy those machine learning models, etc. This, in our next webinar, the path to data science for engineering, we'll go much deeper on this, and we'll show you how do you build such a process like this, and what do you need to learn to become a data scientist. It'll be a double click on examples like this with Ford. Okay, so in the end, not only do we believe that engineers will be key to make this, to do the data science and make it happen, but we also believe at Altair that engineers will actually help to do it better. So first of all, low-no code and practical AI we talked about is essential for any use case and any stage in the journey. It's really, really important, these low-no code, to enable a citizen data scientist, because who is going to do all the data science, right? And engineers will be, we believe, will be key at manufacturers across the world, not just Europe, and at your accounts to become these citizen data scientists and to do this. But we believe also that engineers will help do it better. Not just to do it, but to do it better. How? Because we believe there's a massive opportunity. In particular, there's a lot of CAE people here on the call, engineers, and we believe that the big opportunity for CAE engineers is to complement the non-CAE use cases we spoke about, the warranty use cases, the recall optimization we talked about, and the factory floor predictive maintenance, quality optimization of the robots, and the stamping and the stamping process from Ford, for example. And how? Well, so right now, if you look at that robot again, on the image on the right-hand side, there is data models. So, and machine learning and data is very good at certain things. For example, it's very fast. You can get in real time, and you can score a model in real time, which will tell you and help predict a quality issue. But machine learning has some drawbacks because, number one, often there's not enough data to train the model. So what do? And number two is the accuracy of the model. Well, 97% accuracy may sound great, but we know as engineers that in some safety critical environments, that's not good enough. If the 3% happens, then people can lose their lives. So that's not good enough, right? And on the other side, our 3D and 1D simulation, the physics models and the simulations, the CAE space, are very good and very accurate and proven over many years, but it takes a long time for these simulations to run. You can't run it in real time, right? So we're seeing this combination, this convergence of both. It's being coined, and you'll see and hear more about it, hybrid AI. So combining physics models and data models and the strengths of both to do even better use cases, enrich existing use cases like warranty, and to actually discover new use cases like we spoke about in testing analytics. So for example, we talked about a machine learning model not having enough data at the start. You can use physics simulations and models to generate synthetic data to train that machine learning model. So it's up and running, and it gets better over time as the real data, operational data comes in. The same is the other way. You can take the digital twin use case, you look at the real data, the real loading that's actually happening on that robot, and you can get much better loading fed back into those physics models to do better, more accurate simulations and to improve the product going forward. So I think it's a really exciting time, and we're seeing this trend happen. Some of us have already done it, and we're seeing our customers also making that jump. And I think it's really exciting for us here as engineers in the call that I believe we're going to do it because there's no one else who's going to do it. And being engineers, we always do stuff better, and we'll help to do it better. Again, maybe I want to key in a message that it'll be engineers and computer scientists together, the 80-20. That's how we believe it will mature over time. Okay, so we're just going to do another quick poll. So, which use cases are you most interested in? CAE, engineering and testing, manufacturing, or something else we didn't speak about? Okay. Cool. Let's give that another second. We look like the numbers are stabilizing. We are at 47% CAE, 34% engineering and testing, 15% manufacturing, 5% other. Okay, thank you very much for doing that poll. Now, let's just move on, one or two more slides. So, today was the big picture. How engineers will be key to unlock AI manufacturers. This is happening. It is a new emerging trend. It's super exciting. And I hope I was able to share that trend with you, why that is the case in the big picture mode today. In our next upcoming webinar, the path to data science for engineers, it'll be how to get there, a much more technical, deeper dive. And we'll do a longer webinar to show you what you need to learn and how can you become a data scientist starting from being an engineer. Going forward, we'd like to do some more regular events, invite some of those some guest speakers, and if you would like to give a talk, please let us know, reach out to us. We really want to share the success stories. This is an important movement, we believe, and it's just getting started, and really, in particular, sharing success stories and use cases, which is always the most important, to help everyone here to enlighten the path going forward. Okay, so last poll from our side. Okay, so yeah, thank you for voting on those polls. I'd like to now end the session. I hope you got a lot from this and are as excited as I am about it, and others at Altair. We are, there to help you on this journey, and yeah, we need to talk about this. So if you're interested in doing a speech or being a guest speaker, please reach out to me on LinkedIn or anyone else here at Altair that you know. I'd like to stop there and end the session for today as planned, and open up for the last few minutes we have for any Q&A you may have. Thank you very much for attending, everyone. Great attendance today. So I'm just going to look at the question list. Okay. Questions. So I've got a couple of questions here. My simple understanding of AI and ML is that you need a lot of data. And in the early development phase, data doesn't exist. So what is the first step in getting the data? How can I decide what data to collect, and what quality of data do I need from my AI ML to be successful? Okay, so first and foremost, start with data that's available, ideally. It's all about the use case. So start with the use case. What data do you need is dependent on the use case, obviously. That's always number one. You start with use case, everything. Number two is this topic of big data. You have to have gigantic petabytes of data, etc. That's just not true. So, and most of the manufacturing cases I've seen, very few are at big data today, particularly in this early phase you're at. So you can actually do root cause analysis like we spoke about, and train machine learning models without having big data. And lastly, I would say, if the data still doesn't exist, you can, for example, use that synthetic data we talked about, maybe using simulations to generate synthetic data to train your machine learning model for that new product until it gets maturity on the market, and then you get that operational data to mature further the machine learning model. Let me check for more questions. Now this is even better. We do not. Okay, let me check. So, how can no code be diffused? It seems impossible to me to create software as efficient as code without making it abstruse. How can no code be diffused to create a software? Okay, so I think that was the question that came in before the webinar started. So I hope with the webinar that may have helped you answer that. You don't need to do coding. That's the answer. You can use a low-no code solution and don't have to worry about being a programming guru to make this stuff work. Again, it's important, the 80-20 rule. So you will always need programming. It's not going to be completely no code, because as stuff being the new latest algorithm, there's a lot of open source in data and AI. So the new latest deep learning algorithm, you'll always need an expert computer scientist to develop, use that new technology and develop the new competitive edge algorithm for your company, where you want to protect the IP. And then once that algorithm has been matured, you can then provide it in a stable process for the 80% of the citizen data scientists to use it in their use case environment. Okay, I'm seeing a few more here. It's a lot of questions. Sorry. Let me see. Is it possible to run time series learning? Yes. As model, as ML needs to. As machine learning needs to use a lot of data to start with. I'm still wondering how machine learning can be implemented in CAE problems because each CAE analysis is time-consuming. C's are expensive. Can you please cover a realistic example in the next webinar for CAE? Yes, we can. We can do that absolutely, and I think that's perfect for the next webinar. Okay, just reading a few more here. What are the specific other tools used for machine learning? Okay, what are the specific alter tools used for machine learning that we need to learn? Okay, that came in from Ahmed. Thank you for the question. So there are on the data side, the data tool set. On the CE side, there's various tools like HyperStudy and further tools with using machine learning around that area in the CAE use cases. For the larger, let's say, data use cases we spoke about in engineering and production and testing, there's three data main tools we use. We have a special data preparation tool called Monarch. We have a second tool for a data science platform to do ETL and train machine learning models. And then we have something called Panopticon, which is a standard in the stock market and capital markets, and that's used to visualize real-time data. That we think is also a great tool for IoT applications, for example. But I think a lot of these questions are on the double click, I would say. So at this stage, I'm just going to read out maybe one more question because we're at time. A lot of great questions. I think we'll follow up on these with you, and also a lot of these will be answered by the next webinar, which is a deeper dive into those tools, for example, to show it to you. I just like this last question I picked up here is really cool. How do you see the job opportunities for someone specializing in the subject matter? So stellar is the answer, I would say. If you're able to master and help deploy a warranty use case, a predictive maintenance use case, etc., you will be able to command great salaries and it was in scarce supply, and there will be great career opportunities because AI is going to be pretty much everywhere in every company, in every product and service. So AI is a fantastic future, and if making that jump to data science and being able to implement this stuff is in such hot demand, and you'll have fantastic opportunities immediately in your company and careers going forward, from my point of view. Okay, I think we're just going to end with that. Thanks again for all those questions. There's so many came in, I was not able to answer all of them, and some of them I just don't have the confidence to answer. So we're going to follow up on those. And again, please do join us for the next webinar. Marco, who leads our data science and data engineering teams in EMEA, Marco Flieser, he is an engineer himself who's made the jump to data science for many years, and now he leads our whole technical teams. He will be giving that webinar and showing you how to become a data scientist for engineers. Okay, so thank you everyone for joining. Amazing to see so many people interested in the topic, and hope to speak to some of you in person going forward. Thank you very much. Bye-bye.